Chapter 3, Lesson 3 of Pre-Calculus, looking at logarithmic functions, and we want to look at the graphs in this lesson. We remember from our discussion earlier that the logarithmic function is the inverse of the exponential function. So if we know what the exponential function looks like, we simply exchange the positive x-axis for the positive y-axis, making that turn and flip, and we will have the graph of the logarithmic function. So let's review very quickly the graph of the exponential function, some of its key parts, and then we'll use that to help us with the logarithmic graph. With the exponential graph, which we have pictured here, you remember this y equals 0 is a horizontal asymptote, and the point 0, 1 or 0a is on the graph. So 0, 1, if we're talking about the exponential a times b to the x, where x is 0, then the y would be 1. So these 2 points are on the graph. So if the inverse of that, or you remember with the inverse then, that the x becomes y and the y becomes x. So instead of this being y equals 0 as an asymptote, x equals 0 is going to be an asymptote, and that's going to be the vertical line x equals 0. And instead of 0, 1 being on the graph, the y becomes x and the x becomes y. 1, 0 is going to be on the graph instead. So if we understand what the exponential function and its graph looks like, it's going to be rather easy to graph the logarithmic because it's simply going to be the inverse. So that kind of gives you the overview. Let's go ahead and take a little bit more detailed look at the graphs of these logarithmic functions then. So our logarithm graphs are going to have this same shape as you see here in the picture. Now these are 2 logarithmic graphs. They just have different bases. You remember the log x is a common log, which is a base 10, and the natural log x is the natural log with a base e, which that number is a little bit more than 2. So you'll notice the difference in the shape based upon a base 10, which is kind of a shallow rise up here above the x-axis, and a base 2, or a little bit more than 2, which is a more rapid climb, although again not a very quick climb, but more rapid than the 10. So from that we should have an idea that a base 10, a base smaller than 10 is going to have a steeper rise, and a base larger than 10 is going to have an even more shallow rise as you come through here. So we'll keep that in mind as we sketch our graphs. A couple of other key things we need to know about the graphs. We have a vertical asymptote, here at x equals 0. Again, that's the inverse of the horizontal asymptote from the exponential. So your vertical asymptote here is x equals 0. And this point, you'll notice both graphs go through that. That is the point 1, 0. Again, if the exponent is 0, then you're going to get a value of 1 as your x. All right. So these would be what the graphs are going to look like. You'll notice they're essentially the same because the bases are the only difference, is between the bases. Once we have the general shape, then our knowledge of transformation is going to apply to both of these. Meaning, if you want to shift it right or left, you're going to have a value subtracted from the x. If you're going to shift it up or down, there's going to be a value added on the outside of this natural log x. A negative sign in front is going to reflect it over the x-axis. A number in front is going to stretch that even further vertically, and then a negative x is going to reflect it over the y-axis. So all those transformations that we've been working with over the last couple of years are going to apply. So in order to graph these, we want to put our asymptote on there. We'll put 1, 0 on the graph. That will always be on the graph. And if you wanted a second point out here, the base as your x value and 1 is going to be another point that you could use. Once you have those points, then you can apply the transformations to both the points and the asymptotes in order to sketch the graphs. All right, so let's look at a few examples, and then and we'll show you how you can sketch these graphs pretty quickly using that knowledge that we just talked about. For our first example, let's sketch the graph of the natural log of x plus 3. So we want to remember the 2 characteristics. We have an asymptote at x equals 0, and the point 1, 0 is on the graph. Now, this x plus 3 in parentheses represents a shift to the left 3. So my asymptote that is normally at x equals 0 has been shifted to the left 3. So my asymptote here is at x equals 3. Now make sure you label those as we go forward. Now we also know that there's a point at 1, 0, but again that point is shifted to the left 3. So I now have a point here, and so again I want to label that point, so that's at negative 2, 0. So make sure you label those 2 points as moving forward. Then we know that the graph rises close to the asymptote, goes through one point, and then has a nice slow rise. It's a natural log, goes up here. Now, I notice this is going to cross the y-axis, so I could figure out what the y-intercept is by putting in 0 for x, okay? So this would be the natural log of 0 plus 3, so the natural log of 3 is f of x. And again, that would be e to what power would be 3. Now, I know that e is a little bit more than 2, so I'm going to raise it to a power a little bit more than 1 in order to get 3. So I know that it's going to cross somewhere a little bit above 1 in order to do that. So my graph is going to come through here, it's going to cross here, and it's going to have a nice slow gentle climb, and so this would be the graph of the natural log of x plus 3, and using my shift. Alright, so if we kind of click on that, you'll see I've got a fairly good picture of what the graph looks like. Okay, so again, label the asymptote, the point 1, 0, and then just use your shifts left to right to graph it from there. So let's take a look at another example. For this example, we have a negative 1 plus log of x. Now again, we're not used to having this number out in front as far as seeing the reflections or transformations, but if I put it like this, then we can see it a little bit easier. So there is no transformation right or left. There's simply a shift down 1. So we're going to take our two parts, our vertical asymptote, which is at x equals 0. The shift up or down is not going to affect that at all, so that's going to remain at x equals 0. And then this point 1, 0 is going to be shifted down 1. So this point is now going to be at 1, negative 1. And that's all there is to this transformation. So my graph is going to come like this, and whoops, that's probably not quite right. It's going to, it's log base 10, so the climb is going to be kind of more shallow than the natural log, so it's going to look something like that. So if we click on this, I think we get a good picture of what it should be, and you'll see we're fairly close.